Sports make healthy life. Stay longer in front of computer. Lying down on the sofa with laptop. Eat more snacks but exercise less. Then more people become sub-healthy and overweight. It's time to change your lifestyle. Do sports to make healthy life. Sports benefit people both in body and mental. Joining in sports can keep fit, lose weight and strengthen bone. It also helps people relieve anxiety and fight depression. There are many sports can do in daily life.
A very good day to Dr. Isa. Myself is Anusha Subramaniam and my team will be presenting about the topic of increased participation and decreased performance in recreational master athletes in Berlin Marathon 1092-2019. And our code is BNB 22502, Statistic for Engineering Technology, and we are from Group 3. And this is my crew members, which is myself is Anusha Subramaniam, Lavanya Raja, Khairul Naima, Dineshwaran Arumugam, and Hazelina Anna Hector. This is our today's lesson outline, which is introduction, methodology, results, and calculation. And the last one is discussion and conclusion. Okay, for my part, I will be explaining about the introduction, chapter 1 and chapter 2. Which is I will cover the methodology of chapter 1 and chapter 2 and the calculation for the both topics. For the first slide, introduction. The purpose of this report we are doing is to analyze the provided data set using statistical methods to uncover the patterns, trends, and insights to relevant sports data. And we will also cover 6 chapters, which includes random variable, normal distribution, sampling distribution, estimation, hypothesis, and simple linear regression. The findings will be contribute to enhancing process, guidelining strategies, or addressing the research questions. And the subsequent sections present the methodology, data analysis, and interpretation to ensure a comprehensive understanding of the results and each topics. And I will be explaining about the chapter 1 and the chapter 2's methodology. This is chapter 1 is random variable. Random variable usually measures of discrete data are the items that can actually be counted as their individual or in separate units. And these things cannot be separated at all. And instead, they all can bound to operate in set, stakings, or concentrations. For the chapter 2 is probability distribution, which is probability distribution is a mathematical concept, which is more specifically a continuous distribution, which is referred as a normal, Gaussian, or bell curve, which shows in a graph, and distribution in which half of the values are greater than the average value, which is also the median and mode. And these are the formula this is the formula that we will use for our chapter 2, which z equals to x and u, which is mean, and below is the standard deviation unit.
Hello everyone, my name is Lavanya Raja, and for chapter 3 we focused on sampling distribution, which is crucial for understanding how sample statistics represents the sample population. Sampling distribution describes the variability of a sample mean when repeated random samples are taken. The central limit theorem plays a key role here. It states for a large enough sample size, typically n is more than or equals to 30, the sampling distribution of the sample mean approaches a normal distribution regardless of the population's original shape. This allows us to generalize sample data to the population. We calculate the standard error using the formula S equals to standard deviation over square root n, where the sigma is the population standard deviation and n is the sample size. Using this, we standardize sample means into z-scores, helping us compute probabilities for real-world events. Overall, this method helps in estimating population parameters, testing hypotheses, and determining probabilities.
Methodology chapter 4, estimation. In statistics, estimation is a basic data that entails drawing conclusion about a population from sample data. Without constituting a complete console, the objective to the obtained value data on the population such as mean or variance. Estimation have two, point estimation and also interval estimation. Point estimation involves providing single value. For instance, the sample mean is often used to estimate the population mean, when the interval estimation is a confident interval is a real number between two values that likely to contain the parameter being estimated.
Hypothesis testing is one of the important procedures in statistics that help the research arrive at the decision. In this note form, the basics of hypothesis testing is in chapter. We explore them further and carry out the real-life hypothesis testing data from one of the biggest marathon in the world, which is Merlin Marathon. So we will learn further about the null hypothesis, alternative hypothesis, and significant level, p-value, lastly the decision-making process.
Hello, my name is Hazanina Mao, Anahita Britin. So for my part is methodology, which is chapter 6. The title of chapter 6 is Simple Linear Regression Model, which consists of independent and dependent variable. The Berlin Marathon, held annually since 1974, showed two key trends among recreational master athletes: increasing participation and slower average completion times. Using a linear regression model, research analyzed how participation and performance change over time. This helped identify long-term patterns and predict future trends in the event. Simple linear regression involves two main variables, which is independent variable predictor, dependent variable response. Independent variable predictor, this is the input variable used to forecast the result. In the context of the document, wave height or wave period could be considered independent variable. The dependent variable response is the predict output or outcome. For example, wave run-up height could be used as the dependent variable. The linear regression model assumes a linear relationship between the independent variable x and the dependent variable y, typically expressed as y beta 0 plus beta 1x plus epsilon, where b0 and b1 are coefficient and epsilon represent the error term. The model for simple linear regression is y equal to beta 0 plus beta 1x plus epsilon, where y is dependent or response variable, which is variable to be modeled. X is independent or predictor variable, which is variable used as a predictor of y. Beta 0 is y-intercept of the line, which is the point at which the line intersect or cut through the y-axis. Beta 1 is slope of the line, which is the amount of increase or decrease in the deterministic component of y for every 1 unit increase in x. Epsilon is statistical error, which is random variable that account for the failure of the model to fit the data exactly. The least square method is also used to determine how well a straight line fits a set of data by minimizing the deviation error between observed and predict value of yy. This error represents as vertical distance r squared to give a greater weight to large deviation, while multiple lines may have a sum of error equals to 0. Only one line minimizes the sum of square error, which is SSE. This line, known as the least square or regression line, is derived using the least square method, ensuring the best possible fit to the data.
And for the next slide, we will be concentrating on the data analysis, and we will cover the results and discussion for the 6 chapters, and I will be covering for chapter 1 and chapter 2. These are the databases for our sports topic. My group had collected 30 samples since 1990 and 2019, which consists of year, country, gender, age, and time. Okay, for the question 1 represents chapter 1, and the question 2 represents the chapter 2. And for the question 1, which is the question is increased participation and decreased performance in recreational master athletes in the Berlin Marathon 1994 until 2019, and the number of the recreational master athletes in the marathon in that year according to the gender and the year. And we had a table which consists of X and PX, and the X represents of the age, and PX is according to the age which they contribute at their age for the sports. After that, we will find the expected value, standard deviation, and the variance. For the mean, we will total up X and PX, which we will multiply X and PX and will total up, and the answer will be 1336 over 25. That will be our mean. And the second one is X square multiply PX, which we will multiply or square root every X, and then we will total up, and the answer will be 2866 over 10. The third one is we will find out the variance. and our variance will be 5829 over 25, and the last one is standard deviation. We will use the formula, and our standard deviation will be 53.03. As in conclusion, the expected value of mean is 1336 over 25, and the standard deviation is 2866 over 10, and variance is 53.03 as per the random variable calculation question. And for the chapter 2 question will be probability distribution, and the question is on an average the number of increased participation and decreased performance in recreational master athletes in Berlin Marathon since 1990 till 2019 according to the age of male contestant, and follows the distribution given in the table below. As usual, the table will be remain same, and in this case we will assume the number of male contestants age is 50 and above approximates, and we will use Poisson distribution. And what is the probability? Find exactly 50 age male contestants that happened during of increased participation and decreased performance in recreational master athlete in the Berlin that happened in one day. So in our method, which is Poisson, the value we get is 53.44, and the value of the x we will assume is 50. After we apply the formula, we will get 0.050. And as per the chapter 2, which is probability distribution, I have used Poisson method, and the value is 53.44, and the value for x is 50. That value we have assumed it as per the question, and finally the probability is 0.050 for this question.
Let's move on to the chapter 3 question, which we worked on a question involving the sampling distribution of marathon finishing times for male athletes aged 50 in the years 2010, 2013 and 2019. Let's go through the problem and solution step by step. The question asks us to calculate the mean, standard deviation and standard error of the sample distribution. Additionally, we were tasked with finding the probability that the sample mean finishing time exceeds 4 hours. First, we extracted the finishing times from the data set and converted them to hours. Like 2010, 4 hours 30 minutes and 40 seconds, which equals to 4.511 hours, and 2013 equals to 4.526 hours, and 2019 equals to 4.474 hours. Next, we calculate the sample mean using the formula, and we got 4.504 hours. Then we found the sample standard deviation. First, we must compute the deviations from the mean and square them. Next, sum the square deviation and divide by n minus 1, which equals to 2. Take the square root to get s equals to 0.0268 hours. The standard error was then calculated as SE equals to standard deviation over square root n, which equals to 0.0155 hours. Then we finally determine the probability that the sample mean exceeds 4 hours using the z-score formula. Assuming the population mean is 4 hours, we get 32.52. From the standard normal table, the probability for z is more than 32.52 is effectively 0, meaning it's highly unlikely. In conclusion, the sample mean finishing time is 4.504 hours, the standard error is 0.0155 hours, and the probability of the mean exceeding 4 hours is negligible. This analysis showcases the power of sampling distribution in statistical inference. Thank you.
So for the simple question for chapter estimation, earlier research is analyzing the average finishing time of International Master Athlete in the Berlin Marathon from 1990 to 2019. They collect data from a sample of 30 finishers from the year 2019, finding that the average finishing time is 30 minutes with a standard deviation of 50 minutes. Calculate a 95% confidence interval for an average finishing time of a recreation master athlete in the Berlin Marathon in 2019. So n equal to 30 minutes, x equal to 30 minutes, or set as 0.5 hours, s equal to 50 minutes, set as 0.25 hours. So we need to search the 1 minus 0.95 equal to 0.05. So let's research z. We look at the table form, so we get 1.96. So the formula is x plus minus z and the total of the table. So 0.5 plus 1.96 divided with 0.25 punca kuasa 30. So we get the answer. The minimum is 0.4105. Same as the calculation. The maximum value we get 0.5895. So the discussion is this is based on the sample data. A range of the population mean of athlete in the Berlin Marathon from 1990 to 2019 is between 0.4105 hours to 0.5895 hours.
So let's move to the question, which is the question is the time taken by the male runners at the Berlin Marathon in greater in 2019 than it was in 2090. So the first step is the state the hypothesis statement. So we need to find the null hypothesis, which is HO. So the mean 1990 is equal with the mean in 2019. So the alternative hypothesis, which is H1, so the mean 1990 is less than mean 2019. So the second step is set the significant level. So we need to use the alpha 0.05, which is one tail for the t-test distribution. So the third step is calculate the statistic. So the answer will be 71.54 by using the t-distribution. So the step 4 is we need to find the degree for the freedom. So which is after we use the formula, so we will get the 49217 is as answer. For the step 5, we need to compare the t statistic with the critical value. So the t statistic, we get the 49,217 with the alpha 0.05. So the critical value for the t is for the one tail is smaller than the competitive value, which is 71.54. So the step 6, we need to find the p value. So the p value for the t distribution is 71.54, which is larger than the effectively 0.0. So it means we need to reject the null hypothesis. So the conclusion should be, it is an evidence to support that the reject HO, there is a statically increase in the mean finishing time for the male runners in Berlin Marathon from 2019 to 2019. So the discussion probably this hypothesis testing shows that the data as a good evidence that the average finishing time taken by the male marathon runners in Berlin Marathon between the years 2019 to 2019 has been increased.
Okay, for the question 6 is increased participation and decreased performance in recreational master athlete in the Berlin Marathon 1974 to 2019 and the number of recreational master athlete in the marathon in that year according to the gender and age. Find a simple linear regression using least square method. Formula for the slope beta 1 is b sub 1 equals the summation of open parenthesis x sub I minus x bar close parenthesis times open parenthesis y sub I minus y bar close parenthesis, and divided by the summation of open parenthesis x sub I minus x bar close parenthesis square. The summation of open parenthesis x sub I minus x bar close parenthesis times open parenthesis y sub I minus y bar close parenthesis is calculate 50 minus 55.25 times 0.433 minus 0.25 plus 55 minus 55.25 times 0.3667 minus 0.25. The result is negative 1.8165. The summation of open parenthesis x sub I minus x bar close parenthesis square is calculated as follow: 50 minus 55.25 square plus 55 minus 55.25 square. The result is 50.75. For slope calculation, beta 1, p sub 1 equals negative 1.8165 divided by 50.75 approximately equal to negative 0.0358. Intercept calculation, b sub 0 equals y bar minus b sub 1 times x bar. Then b sub 0 equals 0.25 minus open parenthesis negative 0.0358 times 55.25 close parenthesis, which equals to 2.2279. Regression equation formation, y bar equals b sub 0 plus b sub 1 times x. Then the simple linear regression equation is y equals to 2.2279 minus 0.0358x. So for the discussion of the topic is, this table explains the key aspect of a linear regression model used to analyze the relationship between an independent variable x and a dependent variable y. The slope indicates the rate of change of y as x increase with a negative value showing that y decrease as x rise. The intercept represents the aspect value of y when x is 0. The model assumes a linear relationship, but outliers or nonlinear pattern may affect accuracy. This approach is useful for predicting probabilities and understanding the strength and direction of the relationship. The linear regression analysis models the relationship between x, which is independent variable, and y, dependent variable, using the equation y equals to 2.2278 minus 0.0358 xy equal to 2.2278 minus 0.0358x. The negative slope, which is negative 0.0358 minus 0.0358. indicates a decreasing trend in y as x increase. This suggests an inverse relationship between the two variables. The model assumes linearity and is useful for predicting y based on x, thought it may be impacted by outliers or nonlinear pattern. Okay, for the conclusion is this research analyzed trend in participation and performance among recreational master athletes in the Berlin Marathon from 1974 to 2019 using statistical method. Key approach include probability theory to choose appropriate data, distribution, sampling distribution to estimate population parameters, and confidence intervals to determine plausible value for key metric. Hypothesis testing identifies significant change in trend, while linear regression analyzed the relationship between increasing participation and performance. The study offers a detailed understanding of how participation grows and performance shift reflect broader change in the dynamic of recreational athletes in the marathon. This analysis helps highlight how statistical tools can uncover meaningful patterns, providing insight into long-term athlete trends and their implication. Okay, now is for the recommendation. To investigate trend in participation and performance among Berlin Marathon master athlete, it is recommended to classify data types accurately using discrete variable for participation and continuous variable for performance. Select appropriate probability distribution, such as like binomial, Poisson, or normal, and use reliable sampling methods like random sampling or bootstrapping. Include point estimate and confidence interval for accurate parameter estimation. Apply suitable statistical tests to assess trend and use linear regression to analyze the relationship between participation and performance, ensuring model assumptions are met. Prioritize data quality, use visualization for clarity, and interpret results within the relevant context.